Welcome to physics classes. I am Sarabjit Kaur Sidhu, Assistant Professor in Physics at S. Government College of Science, Education and Research, Jagraon, Ludhiana, Punjab. In the previous lectures, we have studied three different models of specific heat, that are Dulong and Pettit law, Einstein theory of specific heat, and Devashish model of specific heat. Now, in this lecture, we will study the comparison between these three models. So, first is Dulong and Pettit law, second is Einstein theory, and third is Devashish model of specific heat. And first comparison is atoms in a crystal. We know that they are at the lattice sides. They are bounded by some kind of force, and each atom vibrate independently of each other about mean position. ठीक है, vibrate independently. And in Einstein theory, atoms in a solid are assumed to be independent simple harmonic oscillators. And in Devashish model, the atoms are coupled together. They are coupled together to form a continuous elastic body. They are not independent. There is no independent movement. Clear? And the second comparison, each atom that is like a harmonic oscillator vibrates at same frequency. In Dulong and Pettit's law, and in Einstein theory, all the atoms vibrate with a single frequency, which is natural frequency of the system. And in Devashish model, the frequency of propagating wave range from some value to a maximum cutoff known as Devashish cutoff frequency nu d, which is also called Devashish approximation. And there is also a restriction on number of modes of vibration in Devashish model, that is 3n. So maximum frequency is nu d. And next comparison is oscillators are allowed to have any frequency or energy ranging from 0 to infinity. So this is a continuous energy spectrum. But according to Einstein, the vibrational energy of the solid is quantized and a single value, and a single quantized unit is called a phonon. And the value of energy is E is equal to n plus half h nu. For n is equal to 0, the energy comes out to be half h nu, which is 0 point energy. And in case of Devashish, the vibrational energy of solid is quantized here also. Next, the variation of specific heat at high temperature. At higher temperature, all these three laws have same value of specific heat at higher temperature, that is 3R. Specific heat is 3R for Dulong and Pettit, for Einstein, and for Devashish model. And next is at low temperature. At low temperature, Dulong and Pettit law give no results of specific heat. But Einstein, according to Einstein, the specific heat varied exponentially at low temperature. And according to Devashish, the specific heat is directly proportional to T cube. That is T cube. Or we can say that total energy is directly proportional to T4, which is just like a Stephen's law. Clear? And in Einstein, h nu over k is equal to theta E, which is Einstein temperature. Okay? The numericals are based on this formula. And for Devashish, h nu d, which is Devashish cutoff frequency, oblique k, that is equal to theta d, which is Devashish temperature. The last comparison, this gives the value of specific only at higher temperature. This theory gives a lower value of specific heat than Devashish theory. The curve is lower than Devashish curve. And this gives higher value of specific heat than Einstein theory. Then is the comparison of the curve between specific heat at constant volume and temperature. Sometimes here is T over theta E in case of Einstein, in case of Devashish T over theta D. But here we are comparing all three, so I am writing here T. So the curve between CV and T, that is like this. Here curve is here. So this is first curve, dotted line. Okay, this is first curve. This belongs to Dulong and Pettit law, that is classical theory. And second curve is like this. This is of Einstein curve. And third is Devashish, and this is also experimental curve. This is also a experimental curve. So the value of CV at higher temperature is 3R according to Dulong and Pathak. So there is only one curve parallel to x-axis. So this gives only the value specific heat at higher temperature. But in case of Einstein, the curve is like this. The curve is like this. This is not a good agreement at lower temperature. Okay? At lower temperature only gives the values of specific heat at higher temperature, and at T approaches to 0, when T approaches to 0, then CV approaches to 0. Okay, ji? Then next third curve which have dots like this. This curve is the Devashish curve between specific heat and temperature, and it is a good agreement with the experimental curve. The experimental curve is also like this. This gives the value of specific heat at lower temperature, T cube law, follows T cube law, and at higher temperature 3R, and when T approaches to 0, CV approaches to 0. So the Devashish model is a very good agreement with the experimental. Thank you.